Hi, we are from GroupL. I would like firstly briefly introduce our team. We have three members, Jiang Zodong, Jia Yingying, and Xia Mengna. In this study, we have built an application to realize the correlation between the COVID-19 infection and the vaccination. Our goal is to provide real-world evidence to support the effectiveness of the COVID-19 vaccines, because there are still many people are deeply skeptical about the safety and the effectiveness of the mRNA vaccine. Now, I will firstly introduce our project status. This Gantt chart shows the timeline, procedures, and the plan for each task we have finished by following the instructor and the TA's requirement. In the first three tasks, we choose the topic and start to make the plan for implementation and design. Then we choose the best data results, then start to clean and transform the data. In task 4 and 5, we perform the statistics analysis to study the correlation between the COVID-19 infection and the infection and the vaccination. In task 6 and 7, we built our visualization app using Python Dash and Plotly. And from task 8 to 10, we finalize our application. And all the three members contribute equally to this project. And the deployment of the app will be introduced by Mengna's part of presentation. Okay, let me switch to our app. The app's name is called COVID-19 Vaccination Effectiveness Analysis. And to support our hypothesis that the vaccination can reduce the infection, we firstly plot the vaccination data with all different COVID-19 infection data, including the number of the new cases and the number of the hospitalization patients and the ICU patients and the number of the Delta variant cases. And this data was normalized between 0 and 1. On the left side, we have a drop-down box to select 9 different countries. And if we pick different countries, the data and the plot will be updated accordingly. And we also have the checkbox to select the specific data. And we also built a ranger slider to choose specific time range. So the default time range will be between the January to September in this year. And let's use the USA as the first example. And the time range is from January to September this year. And from this plot, you can see the number of the total vaccination, which is in the purple line, is negatively correlated with other infection data in other color lines. The correlation score was shown in the table in the bottom, and for example, the correlation between the vaccination and the new cases was negative 0.26. And this result indicated that the vaccination could have a negative effect on the COVID infection. Similar results also found in other the correlation between the vaccine with other infection data, such as the correlation between the vaccination and the hospitalization is negative 0.3. So we also found similar results in other countries. You can see here with the correlation between the vaccination and infection is always negative. But you know, correlation does not always imply causation. To support our hypothesis that vaccination is the cause of the reduced COVID infection, we perform a Granger causality in time series analysis, which is a standard statistic hypothesis test for whether one time series factor can forecast another time series factor. In other words, if one time series is the cause for another time series. So, and the Granger score between the vaccination and infection are showing also in this table, and the p-value is obtained from the ADF test which is also called augmented D-key folder test. So as we can see, if the p-value is significantly higher than the 0.05, then we can include that the first factor is the cost for the second factor. If we use the first row as example, it means that the vaccination as the first factor is the cost for the new cases as the second factor, because the p-value is 0.48. In other words, the vaccination came first, not the new cases came first. By following the same method, the results also indicate that the vaccination greatly caused the hospitalization and the new deaths in this table from the US data. So in most other country data, this is Australia data. So in most other country data, we also have the similar results. So in summary, and from these two types of statistics analysis, our results support our hypothesis that the vaccination is the reason for the decreased number of the COVID infection cases in this year. Okay, let me switch to Ying to introduce other function in this app. Thank you.
I'd like to introduce another feature about our web application. Besides, we further enlist the United States COVID-19 related data, and we compare the fully vaccines population with unvaccinated population to confirm our assumptions. As the screen, you could see in the United States and unvaccinated population, the infection case of unvaccinated population is 7 times to the fully vaccinated population. If we collect this death bar, it will show the death population, the death percentage in fully vaccinated population and unvaccinated population. And we analyzed each vaccine. In United States, there are 3 vaccines approved by FDA. They are Johnson, Moderna, and Pfizer. We could see from our analyst, you could see all of these 3 vaccines have a much have a very good effectiveness. But compared to if we compare each other, Moderna and Pfizer is much better than Johnson. Also, besides of that, we also analyzed the vaccine effectiveness in different groups. From this data, you could see vaccines have a good effectiveness in all age group. So that's all about our application and analysis. Besides of that, our application still, besides of time limited, our application still have something needed to modify. Such like we'd like to, in the future, we'd like to compare our database to the public database. So to achieve our application update, autumn update every day. And besides of that, I'd like to visualize our data on a group, on a map, so it will be easier. It will be easier to read or understand our analysis. On the other side, we could do the further analysis. Recently, there is a new variant, Omicron COVID-19. The effectiveness of COVID-19 vaccines to this new variant is still unknown, and it will be interesting and useful to get the analyst result. Besides of that, I think if we get COVID-19 data about pregnant women or young children, this special population, to analyze the effectiveness of COVID-19 vaccines in this population, it will be much useful and interesting. So that's all about our introduce. Thank you very much.
Hi, this is Mona. I'm going to present 3 parts: our GitHub repo, then I will show how to run the web application locally, and finally our deployment on the Heroku.com. As you can see, this is our GitHub repo for the group project, and you can start to learn more about our project by starting off the README file. The beginning is a brief introduction of our project. In summary, we build an interactive web application to display our COVID-19 vaccine effectiveness analysis. Also lists out the web application address. I will show you later in this video. Below are some details of our source code. Here is the file list. This file is the source code of our web application. You can click it to see the details. And then here is the data set we use to produce our web application. And you can see I put the data reference link here. So you can click to see some of our detailed data. Following are the directories and the file links in this repo, so the reader could go to the file conveniently. Like you can click the user menu and then it will show you the application menu of how to use our web application. Right now I'm going to show you how to run the web application locally, and here is the instruction. Since I already have the project folder on my computer, I don't need to clone the repo. So you can go to the project folder first. And then you can see this is the command to run the app file using the virtual environment under the folder. Then this is the address that we can see. We can see our application. You can copy that and paste into an address. And then this is how the web application runs locally. And then you can change with the country. And then here we'll change accordingly. Then if you want to stop running the program, you can go back to the command line and then press Ctrl-Shift-C, and then it will stop. And then I'm going to show you our web application deployed at Heroku. You can go back to the repo and then just simply click this link, and then it will be loaded. This is deployed on the Heroku.com, and then it's the same. It will look like the same as the one that we deployed locally.